Welcome back. This is Mr. Hassan's Maths channel, and I'm now answering question number 5 from actually the C1 Solomon F collection. This is C1 is now kind of like P1, the new syllabus. So it's from integration of P1. That's the topic, and it's question number 5 from my worksheet, and question number 10 from the C1 Solomon F paper. And here we've got a question that tells us about the curve C has equation y equals f of x. We're told that dy dx equals 8x minus 2 over x cubed, where x is not equal to 0, and that point P11 lies on this curve C. Find an equation for the tangent to the curve at P in the form y equals mx plus c. So we know that when you have a curve, say that's the point P. Of course, it's not accurate. I'm just drawing just any random curve or part of a curve. The tangent to a curve is a line which has the same gradient of the curve at the point at which it touches the curve. So this line, if it touches a curve at P, right, and it just brushes past the curve at P, so it has the same gradient of the curve at P, this is the tangent to the curve. And we need to find the equation of this tangent. Okay, we've got to find the equation of this tangent. Now, the tangent is a straight line. To find the equation of a straight line, we need two bits of information. One of the things we need is the gradient of the line, so we need the gradient of the tangent. And the second thing we need is any point on the line, which we actually have, which is the point P11. So we need to find the gradient of this line at the point P. Okay, now what they gave us in the question is dy dx, which is the gradient function. This is not the equation of the curve. This is the gradient function for this curve. So the gradient of the point of the tangent, the gradient of the tangent at the point P is going to be what dy dx is when x equals 1. When x equals 1, because that's the y coordinate, the x coordinate of that point P. So we just have to take dy dx and replace the x with 1. So you have 8 times 1 minus 2 over 1 cubed, which is 8 minus 2, which is 6. So the gradient of the tangent is equal to 6. So with that information, we can find the equation of the tangent. So we can use our formula y minus y1 equals m times x minus x1. So y minus 1 equals the gradient 6 times x minus 1. So you have y minus 1 equals 6x minus 6. So therefore, y is equal to 6x. You've got to add 1 to both sides, so 6x minus 5. That is the equation of the tangent to the curve at the point P in the form y equals mx plus c. Okay, pretty simple question there. Now for part B, it says find an equation for the curve C. So we're given the gradient function, and we have to use this and the point that's given to find the equation of the curve C. So what we can do is we can take our gradient function, and we can, when we integrate this, now I'm going to get it ready for integration by writing it as the index form 2x to the power of minus 3. So you write the x cubed, which is in the denominator, as x to the power of minus 3 in the numerator. That's like preparing it for integration. So y is equal to the integral of 8x minus 2x to the power of negative 3 with respect to x. So that will give us 8x squared over 2 minus 2x to the power of minus 2 over minus 2. We have to add 1 to the power and divide by the new power. So this is power 1 becomes 2 divided by 2. If you add 1 to negative 3, you get negative 2 divided by negative 2. And then don't forget the plus c. We're going to have to find what that c is in this question as well. So now let's simplify this a little bit first. So you have y equals, this is going to be 4x squared plus, the 2's will cancel, x to the power of negative 2 plus c. So that's now the equation of the curve, but we need to find what c is for us to give a complete answer. So we know that when the point 1, 1 lies on c, so if we replace those values into this equation, so we have 1, 1 lies on the curve C. So if we substitute those values in, instead of y, we can write 1. Instead of x, we can write 1. This is like 1 over 1 squared plus c. So this is 1 equals, that's 4 times 1 plus 1, that's 5. So therefore C is equal to 1 minus, sorry, what am I doing? One equals 4 plus 1 plus C. So 1 equals 5 plus C. So C is equal to 1 minus 5, which is negative 4. So C is equal to negative 4. So we can say our equation, therefore, is y equals 4x squared plus, you can say 1 over x squared minus 4. That's the equation of the curve C. Okay, so we had to integrate and find the value of the constant of integration by using the point 1, 1, which we substitute the values in, and we find what C is. So that answers part B. So that's our equation, 4x squared plus 1 over x squared minus 4. So I think we need that here. So y equals 4x squared plus 1 over x squared minus 4. That's the equation of our curve C. So let's just make sure that I haven't copied that wrong. That's right, minus 4. Minus 4. Okay. Then part C says, find the x-coordinates of the points where C meets the x-axis. Now, something meets the x-axis when y equals 0, because that is the equation of the x-axis. The x-axis, everywhere on this line, y is 0. The x-axis is y equals 0. So if I take this equation and replace y with 0, I've got 4x squared plus 1 over x squared minus 4 equals 0. Now the first step in solving an equation like this is to get rid of the fraction. So if I multiply both sides by x squared, this becomes 4x to the power 4 plus 1 minus 4x squared equals 0. So we end up with 4x to the power 4 minus 4x squared plus 1 equals 0. Now what we have here is what's called, you could say, a disguised quadratic. Okay, you have a term x squared, and this is the square of that term, x to the power 4. So to make it a bit easier to digest, we can say let's call x squared, let's call it b. So this will become 4b. That's plus 1, that's 0. But this now, that means b squared is x to the power 4, right? So this is going to be 4b squared. So let's find what b is, and then we can use this to work out what we need, which is what x is. So now we can actually factorize this. Okay, I think 2. Can this factorize? 2b minus 1 squared. If you square this, you're going to get 4b squared. If you multiply these together, you get minus 2b times 2. That's minus 4b, and yes. So this actually is a perfect square. So you can say 2b is equal to 2b minus 1 is equal to 0. So therefore b is equal to a half. It's got like a what's it called? It's like a repeated root there. So b is equal to a half. So therefore we can say x squared is equal to a half. So x is equal to the square root of a half. Now we want to write our answer in simplified form, in the form k root 2. So what I'm going to do here is this is like 1 over root 2. 1 over root 2. Okay, so if I multiply the numerator and the denominator by root 2, I end up with root 2 over 2. So we can say, therefore, we can say x is equal to 1 over 2 root 2. Okay, so in the form k root 2, so k is a half, x equals half root 2. They only wanted the x coordinate. There's more than 1 point, so it looks like there's only 1 point here. 1 second, let me just check. No, of course there's not 1 point here. There's 2 points, because of course when we have x squared equals a half, when we find the square root of this, you can have either plus or minus a half. We're putting the square root sign there ourselves. So this is plus or minus a half, okay, 1 over root 2, which becomes plus or minus a half root 2. So that's why it says you've got to be careful here. See, that's an important thing to realize. It says find the x coordinates of the points. So that's a little clue. There's more than one solution. So if you do forget that, which is quite common, then you should realize it says points. So when you take the square, when you've got x squared equals a half, and you are putting the square root sign there yourself, it's not there in the beginning. You've got to consider both the positive and negative square roots, because we know because we know that the square root of a half times the square root of a half gives you a half, And negative square root of a half times the negative square root of a half also gives you positive a half. So there's the answer to part C of this question. Okay, you form what's called a disguised quadratic out of it. All right, so that's question number 5 from the end of topic worksheet. Question number 10 from the Solomon paper. Other questions from this particular paper can be found, the Solomon F paper can be found in the playlist over here. That's P1 Solomon F. Other questions from this end of topic worksheet number 9 on integration from P1 can be found in the playlist in this area over here. You can subscribe to my channel by clicking on this link. Thank you for watching and see you soon.